Hello. In this video, we're going to create a voice using additive synthesis. Additive synthesis, unlike subtractive, is where we build up our voice using multiple individual frequencies in the form of sine waves. Within the modular environment, we're going to use multiple voltage-controlled oscillators. These are all the wavetable ones from VCV's free collection. And to build up our voice, each oscillator, each sine wave, is tuned to a specific frequency in the harmonic sequence. This sequence is simply the fundamental or first frequency, the lowest one, and multiples of it. So as we go from our fundamental frequency of 261.63 Hertz, we simply double that, triple that, quadruple that, etc. Then we take all of those individual sine waves and mix them down. You'll see here that we're using multiples of the VCA mix, so we can take each group of 4, mix it down, and then finally we put that into a mix to sum it all together. Depending on the relationships, the amplitude relationships of all of our different frequencies, we can create different waveforms. In this case, in addition to the audio in blue routed to the mixers and over to this oscilloscope, I have all of the harmonics, all of the additional VCOs synchronized to this first one. And then the first one is also routed into the scope. So we can see our fundamental frequency in yellow, and then we'll see our additive voice in blue. To start, we're just going to bring up each individual harmonic and listen to how that adjusts our sound. This is the fundamental only. Adding the second harmonic. Third. Fourth. Fifth. Sixth, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th. And then removing them. You may have noticed as we added those harmonics, the relationship of me slowly lowering the total amplitude of each subsequent harmonic created a sort of sawtooth or perhaps reverse sawtooth wave. And then as I removed them, you likely heard a sort of similar experience to that of sweeping a voltage controlled filter as we sequentially removed each upper harmonic all the way down to our fundamental. All of the different standard waveforms in synthesis have very precise formulas for creating them out of additive synthesis. And that works really well for digital synthesis, or if you're coding something, or if you can use the math directly to generate it. When patching something together, either in a virtual modular like VCV Rack or in a physical modular, it can be a little bit more difficult to be that precise. But if we look to a square wave as a common other waveform to generate, we can think about its formula, which is a little bit more simplified than some others. For a square wave, we're going to only use odd harmonics. So we have the fundamental, the third, fifth, seventh, etc. Then every harmonic, its amplitude is inversely proportional to what harmonic it is, or its partial. And so we have 1 or like full at our fundamental, and then the third is 1/3 of that full amplitude. And then the fifth would be 1/5, the seventh 1/7, 1/9, 11th, etc. So let's listen to my approximation of a square wave with only 16 harmonics. You can see it sort of plateauing here, though my relationships are not quite right. So we can see that it's a little bit rounded. But if we boost it, maybe we can get a better example. You can see how it sort of reshapes, and we're getting the flat sides of it here, but we're not quite getting it to flatten out as well on the top. You can see from our sine wave with the yellow, we've gotten much closer to a square. And to build it back up again. This idea of adding additional harmonics or frequencies to our mixture to change the waveform can go up and up and up and up. Oftentimes, you'll see harmonic oscillators, and they'll have somewhere like 8 harmonics. That's fairly common. But in a virtual environment like VCV Rack, you could really explore going up to 32, 64, some crazy number of harmonics. And the more that you add, the more detailed that you can get with your waveforms, and the more interesting you can sort of shape them. To take our square wave that we've made and complete its structure as a voice, we need to simply add a final amplifier and an envelope generator so that we can turn the signal on and off, or open and close that amplifier, and shape its amplitude envelope as we play it. We'll also use this MIDI to CV device. When working like this and using a lot of different oscillators, we need to keep them synchronized, and so we will want to take the volt per octave output from our MIDI to CV device, and we'll send that to each of the VCOs. In addition to connecting the volt per octave output from our MIDI to CV device and hooking up our envelope generator, I've also gone and changed the relationship of a bunch of the different harmonics to show a different sound. And now we have an additive voice that is fully playable like any other. This, of course, also works with polyphonic input because all of our modules are the VCV based one. But just like with any of these, we're going to be mixing so many voices together at this point, so many oscillators, that we'll want to turn down our main level. And even this, it may clip somewhere else in here. And that's the basics of making an additive voice in VCV Rack. In addition to adding more harmonics or adjusting their amplitude, consider trying modulating the amplitude with LFOs and having your voice shift around. Consider breaking out of the basis of additive synthesis and using triangle waves or something with additional harmonics and seeing how those all blend together. Or consider adding frequency modulation or changing the phase of the various harmonics that you have. All of these will produce different results, and it's a great foundation for continuing to learn synthesis.